Hello and welcome everyone to the presentation of the real-time metrics and analytics project done for the Codefest 2017 by the Kasukabe Defense Group team, which consists of myself Vikhar, Ulhas, Shailendra, Pruthvi and Faizan. So let's look at the problem statement that we're trying to solve here. So we all are aware that a lot of our products in the suite get faced by performance issues like either slowdowns, systems not loading pages at the correct time, or crashes, and similar other issues of that sort. So generally, this causes a lot of pain to the customer when they are trying to use the system, and also support is not very well equipped to identify and troubleshoot the issues, which then causes them to reach out to the engineering team, and it forms a cyclic loop between the dev teams, the customer support, and the customers themselves, where we're trying to figure out what went wrong, get the information, and then try to debug and solve it. And this is usually a long process and causes a lot of heartburn for both the support teams as well as the customers and as well as the engineering teams. And as of now, we have no form of auto healing or places where the system can itself detect the problems or at least suggest what can be fixed. And also, we are completely unaware as to how the systems are being used in the market today. We do have some amount of awareness in terms of the features and the critical areas of the products, but in-depth information or precise information as to which feature is being used in what way is all at the moment not visible to us. And we also have a lack in the risk analysis whenever trying to do a fix in a particular area. And so these are all the various problems that we are trying to target by our solution. So the solution consists of a low-cost, platform-independent, and scalable utility that can be deployed on almost all the suite components. This utility would provide us information, real-time information in which would help us in detecting of these issues and allow us to do proactive troubleshooting rather than reactive troubleshooting. It'll also, even before the customers know it, we would come to know about the pain points or the problems with our customers, and the system would collect enough information from the logs and from the other information sources using this open source utilities, and we can get all this collective information and help us identify the problem and give a quick solution or a workaround to these problems. As of now, it's just in the starting stages, and in future we plan to introduce some form of auto healing or self healing, wherein we can configure actions to be done based on specific events, such as maybe space consumption in the different folder structures, maybe like the logs, where we could help automatically truncate the old logs or clear the old backups if applicable. And future can also hold the potential in terms of machine learning and anomaly detection by these utilities that we have in place. And these utilities, as they are able to collect data and provide us real-time information, they can also be used to give us smart information about the data which people are using and allow us to do analytics and all that. So with that said, now I will hand over this to Ulhas to explain the architecture and the how part of it.
Hello guys. So uh, as a part of architecture, right? So these are the components, appliances. So these are the components sits on appliances. Take an example of Collective. So this is a kind of utility which captures the CPU utilization, so memory consumptions, the network statistics, and then database part of it. Like what are the queries are being executed and how the query is taking the time and etc. So we have the same utility which is a telegraph which can sit on Windows system. We have the log stash which captures all the logs from the applications. Take an example of EPAs, right? So we have different types of the logs where we capture the EPA request and then performance related things and etc. That can be passed by using the log stash. And we have a Kafka connector which is a JDBC connector which captures the data from the databases, and all these things can be pushed to a Kafka, which sits on a cloud. Okay, and then further from the Kafka we can take that to InfluxDB, which is a time series database, and from the InfluxDB we could generate a different types of the charts and bars, everything in a Grafana tool. Parallelly, we have the data from Kafka to be pushed into an Elasticsearch, and Elasticsearch, and we use an Kibana tool to display all the statistics from the Elasticsearch. Right. So in a future, we are trying to use the Kafka streams and use that data to do a machine learning on it, and get a different aspects of the data.
Now moving over to the demo.
So this dashboard shows the OS metrics of one of our QA servers, speed R820, and this shows us various metrics of OS health like 5-minute load, how many users are logged into it, free memory used, and all that stuff. And you could add any kind of visualizations here. So this allows us to create multiple dashboards. So you could have a dashboard for system metrics. You could have one for Postgres and all that stuff. So you could have it per host basis as well, right? Go back. So I'll give you an example of one of the charts of load average. So this is the load average chart, right? And as you can see, it is showing you the short term, medium term, and long term load averages. Also, you could configure alerts on this. So you could say that, okay, the load average, if it increases above 5, you can give me an alert, and the various channel. There are various channels applicable for it. You could either use Slack, PagerDuty, OpsGNA, and various options available, right? And you could see whenever the alert is reached, this box starts glowing, and it shows that there's something wrong with the system. And so as soon as you receive an alert, you can go and check which metric was wrong in the system, and you could take corrective actions there, right? And then I'll show you another dashboard is DevBox, and this is driven from a Windows system. So we have Telegraph, which is sending us the OS health, and it is being shown here, right? So same kind of metrics you could see for a Windows system also. So depending on the type of OS that you're using, it is there are different regions applicable, right? So you have CollectD for Linux and Mac OS, and Telegraph for Windows, and you can have any kind of application event that you can send to the time series database, and it can be shown here. So I can next will show you the Postgres overview. So this is showing what is the load on that Postgres server, IO, what is the network usage, and then how many. This is showing, the chart is showing rows, updated, return, inserted, and so those kind of metrics, right? And so next I'll switch over to Kibana. So we have hooked in Apache log here, right? And it makes it very easy to search Apache log. So let's say, example, you want to search which all requests succeeded. So you could type 200 and it will show you all the requests that succeeded. You can type any term and it will give you the results for that query. You can build powerful visualizations on top of it. You could enrich this data, let's say Apache logs. So you could enrich this data with geolocation, and it could show you all your users on a map. Okay, this heat map is from a Facebook project called Claspin, and which Facebook uses to monitor their servers. So the constraint is that they wanted to fit all of their server health on one screen, and this is where we want to go. So each of these dots represent a server and its health in terms of various metrics. So they calculate a score based on various metrics like load average and all that, OS metrics and all that stuff. And if some of the servers are failing, then you see a red dot there, and you see orange, like this will turn red in some time, and then green dots. So imagine 700 customers of Pace, right? And we could show them in a heat map, and each of their data is each of we collect the data from each of them and show it on this heat map. And whichever server has some issues, it will show up in red. Then you click this, and we take back you back to the visualization that we just showed, and then you figure it out what was the root cause of this issue. Was it the load average was higher, or is that a capacity problem in our code, or any such thing? And this framework is a general purpose framework which could be leveraged with any kind of application event, as long as you write your inputs and the way to pass them. I mean, you could fit any kind of event, and this could be used with other products like Vision or DSF or any other system, because it is the agents are supported on all platforms, Windows, Mac OS, and Linux. So this could be leveraged across all of the products.
So that brings us to the end of the live demo. Thank you, Shailendra, for showing that. Now let's just wind this presentation, so showing you the benefits out here. So as you can see that depending on the kind of product that we may have, there's a plenty of cost savings in terms of the time spent by the support teams and engineering teams in identifying and troubleshooting of these performance issues. And we just took up the Pace as one example. So we have roughly about total of 140 support cases for the last year, which shows various things such as upgrade problems or system shutdown problems or slowness problems. So all that consists of totally 140 cases for just 1 year. And usually the number of JIRAs that trickle into engineering comes up to about 1 or 2 items per month. And so we took a rough estimate of a few hours spent by the dev and support teams in trying to resolve these, and we could potentially be saving per product $60,000 annually. And this will just increase with the number of products that we have in the suite portfolio. And one of the main things would be the customer happiness, which you will achieve by this solution that we are trying to offer. So rather than being a reactive approach, that definitely a proactive thing will make customers feel more happy about the way we are handling their things. And based on these issues, like the way the servers are behaving, we can also proactively help them in better upgrade plans or future releases and all that. And also for the QA teams especially, it makes a lot of difference in identifying the real world live cases where we see performance issues or problems in the system. This will help us. And although right now the analytics app is not yet there, but once implemented, this definitely brings in a whole set of advantages and benefits along with it, which are pretty much evident to everybody. So with that said, thank you everyone for having seen this demo. And if you have any questions, please feel free to get back in touch with us, the Kasukabe Defense Group. Thanks and have a great day.